put this back in because most people don't use transmission anymore. It's all on the ATR.
Okay.
I can't think of any experiment that any modern industry or college would ever use this for. But you can use it if you want to. Yeah.
Is this the old style disc mount?
Yeah, exactly. No one. I haven't seen anyone make pellets for
just out of curiosity,
decades.
how would the disc sit in there? Is there
Oh,
something to
you'd
hold
have. You still got the holders on that one. Yeah. So the holder just.
Okay.
slides
Yeah,
in
don't
there.
mind me, I'll catch it.
Yeah, there we go.
Okay.
So it just sits in there. Then if you did ever want to decrease the beam width, you would use those manual J stops.
Got it,
But
yeah. Okay.
yeah. But you
Fair enough.
you
That's,
probably won't ever use this.
I like to
so,
connect
but so
present to past.
yeah. Oh yes, well you've got the press. So, okay, so what I'll do to start off with is we'll just make sure this goes green. So that means it's on. So the service engineer tells me just to always leave it on green and just leave it on. But it is, if you want to go into power saving mode, you can press it and it will, that will go to orange and it will go into low power mode. It doesn't really use much power anyway. It is a completely sealed system. This old one you have to leave on at all times. This one you can unplug it if you're not using it over the summer. You don't need to keep it plugged in. It's a sealed system. The desiccant's here. I've never had a customer change the desiccant though. I've been doing this for 5 years and I've never had them change it. There is a humidity sensor in the software I can show you.
Okay.
It always reads 0.
So all going well, it should last indefinitely with the same
yeah,
desiccant.
exactly.
Is it the typical KBR disc that you saw in the old?
Okay.
No, those are.
It's I can't think. It's the sort of blue.
I don't know what. I don't think it's KBR though.
I don't know what it's made. It goes blue when it
Yeah.
gets wet. So
Oh,
you know.
you mean the desiccant?
The
I
desiccant,
meant the
yeah.
lens inside the.
Oh no! So the lenses are KBR here, but they have a film on, so they'll never. You don't need to worry. So just be careful. Students don't scratch this. However, the ATR is probably going to be in there the whole time, so the chance of these windows getting scratched is.
Okay.
So that window right there.
Both of them. Yeah.
Gotcha. So that's the KBR sort of encased, as you said.
It's got this sort of coating on it. to
Unlike
stop-
that one when it's shut off and it went bad.
Yeah. So this one you keep the source on because it has a bit of heat. It drives away the moisture, and then the desiccant there you change every 6 months to keep the moisture away. This one there's no heat for that.
Nice.
So, yeah. So yeah, should be easy to use. Yeah. Okay. You're probably familiar with FTIR, but the source is back here. There's an interferometer in here, which is is a split mirror pair. We have a patented technology called Dynascan, where the mirrors are actually on a pivot here, and they actually just pivot backwards and forwards like that to set up the interference pattern. I don't know if that one has it, but most FTIRs have a mirror which goes back and forth. Now the problem with that is it can go out of line over time, or the drive can get stuck and then it sort of starts juddering. Whereas this, because it's on a single rotational axis, it shouldn't. The interferometer should last for decades as well.
So no longer the traveling mirror, so to speak?
No, well
It's a
it's
pivot.
traveling, but it's traveling.
Oh, okay, pivot, okay.
It's pivoting, so that is called we called it Dynascan. So that's the way the interference pattern is set up. So.
Now this makes sense, because that's what Jeff was asking about.
Yeah. Oh yeah. So that's the. Then it goes into a few lenses and then gets shot through either your transmission accessory, wherever I put it, and then into the detector over here, which I don't know which one I sold you. I think this is the lithium tantalate detector, which has it has a wider spectral range, but it's not quite as fast as the zinc selenide. I can't remember the other detector.
Okay.
Yeah. So
what width is available?
I think it's 8,000. This is off the top of my head. I think it's 8,000 to 400 wave numbers.
It's
Wow.
very similar to this one, I think.
But higher, we don't.
Yeah, you actually go into the NIR.
Okay.
has got
Interesting.
it has a tiny bit of it. It hasn't got the full, like NIR goes up to, I think it's 80,000. So
Oh, I see.
but it has a tiny bit of NIR in
Okay,
there.
interesting.
Yeah.
We don't know what you're seeing up there. We can probably set the parameters on that, but it'd be interesting to see what
Yeah,
else.
most people set it. Well, I'll probably set it today at 4,000 to 450, and
Yeah.
you leave it there forever. But that's the that's the normal range for mid. But it has flexibility to go up. There's the NIR is just overtones of the mid IR. So I don't know if you play musical instruments, but if you're like on a flute or something, you can get the same note if you hold the keys. You just get a different resonance frequency, like an overtone. That's the same in the NIR. So if you looked at NIR spectra, it just looks really lumpy. It's just because it's the overtones of the mid. So NIR is just used for different purposes.
Hiram Walker's uses that for ethanol, as in which stretch or bend they can pick up in the NIR and monitor ethanol content sort of on the go.
Yeah.
I don't know what wavelength,
Well,
wave number they use for that.
Well, OH is you probably know your IR.
Well,
spectrum.
3,300.
Yeah, exactly. So it'll be very high up in the NIR because it's the overtone. So it's probably in the 60,000. It will be a
Okay,
big
so we
lump.
wouldn't be able to pick it up.
No,
Okay,
no.
all right.
But you'll get this characteristic OH stretch in up in that 3,300. I can't remember any of
Yes.
those numbers. Where was I? Okay, so that's a very sort of overview, and then you've purchased the ATR accessory, which is this guy.
I didn't want to touch it.
So this has a clutch on it, so you can't over tighten it. Like you should teach students they shouldn't be just reefing on it forever.
It slips at some point.
It will slip at the end. But you should. I can show you they shouldn't be doing that. But just for you to have knowledge that you can't actually over tighten it.
Okay.
Okay.
So how do they know when to stop? Is it by
There's
feel?
there's a gauge in the software. Then there should be some shoes, which that's what maybe. Did you see those in the
I don't
package?
know. Everything. Oh,
I don't know, maybe it's in there.
Oh, yes, maybe in here. So that's a bib if you want to use it to place over there to keep it clean. You can buy more of those if you
I
like.
gotcha.
Okay.
Yeah.
this one. What is this? Oh, this is sample.
They're little
holder.
metal feet which fit onto this O-ring. So.
What is this one, Tom?
That's if you want to have if you want to reference the ATR, you can put it on there.
Oh, it
Or
gives you
reference
a-
sample?
Like a,
Yeah.
like a
Yeah.
PVC type.
Yeah, like a
standard.
polystyrene. There should be. There they
Oh,
are.
these?
Yes, yeah. They usually ship a polystyrene standard as well. Okay. So the way the ATR works is we have three different feet, shoes, I don't know what you want to call them, accessories, depending on how much pressure you need to apply to your sample to get a good reading. In a teaching lab, you probably will only ever use this one, which is the sort of, the universal type one, which doesn't give too much pressure. It has that size foot, and these just slide on here. Now, these are notoriously, they go walkabout in teaching labs, so just
Okay.
make sure it doesn't.
Okay.
But you can buy
Okay.
another one.
Back up.
They're cheap. Like, this one has a hole in it, and that's for really, really, really volatile solvents. So if you wanted to get a spectra of, there's probably only two, acetone and maybe DCM, that you would use this one. The rest of them won't evaporate quick enough to get a reading, so you probably won't ever use that one. That's what these posts are for, to keep them on there, but I probably wouldn't do that in
No.
the teaching lab either. They'll go missing.
So the other one is, sorry Tom, this
other
one
one's-
is for very volatile.
Yeah, so
that one is.
I doubt you'll ever use
Yeah,
that.
it's gonna be-
Yeah, and this is if you have, say you want to do like a credit card or something, and you need to get a greater contact with the diamond. You would use that one because it's got the area on that is smaller than the.
So like a polymer sample?
A bead or something like that.
It's if you the way ATR works, you need to make sure it touches the diamond
Gotcha.
very closely. So if it's not touching, if you're not getting enough pressure to get a good reading in the preview window, you just change the shoe to that one, but
Gotcha.
you'll probably be fine with this one. It's just, you know, the area is smaller on that, so you
Sure.
get a greater pressure. Yeah.
So it just
Physics
slides
lesson.
in.
So that just
Tom?
slips up and
Yeah.
it doesn't
Sorry?
drop
Just
off?
slides
Yeah, it's
in.
like
Yeah, it's on an O-ring, so
Is it kind of snagged in or
like a
is it
little
just loose?
O-ring bushing.
yeah. So
Yeah, okay.
if you get too much solvent on this, this can, you know, get wear out. But
That's right.
we can sell you more of those. That's probably like $5.
So we got 2 backup items already.
Yeah.
Yeah, yeah. So, but if you leave the shoe on and don't ever take it off, you probably won't need to change that either.
Okay. How do I know like the catalog number or something for that?
I would have.
I just
that
have to look it up on the catalog.
envelope?
No, like I'll buy this one.
Oh, I see.
But the O-ring thing.
Email me,
Okay,
and I'll
okay,
get the.
okay.
Because I'm the sales rep.
Okay.
I'm not.
Okay.
I'll get a product specialist
Thank you.
or the service engineer
Okay.
to tell me which one to buy. So, yeah. Okay, so let's get it turned on. So you'll come up in the morning, the afternoon, whenever. Make sure the green light's on. I heard the USB connection connect. So then we'll come here. Double. So there's only 2 softwares you need, which should be probably similar to this. Is Spectrum IR and Spectrum Quant. We'll go over Spectrum Quant later if you want to make a quant curve to use in the main software. If you want to make a calibration curve. So to open it, you double click.
Administrator.
yeah.
I didn't change it.
So I'm okay at spelling this when it's when I can see it. I'm terrible at.
You good?
Okay. And I can turn that off if you don't want a password because it's,
Yeah,
it's,
probably
it's,
we
it's
should.
annoying.
Yeah, probably we should. Our student, they don't need the password.
Yeah. Okay, so it's the way you've set it up is to automatically connect, and so you can tell it's connected because down here it says PerkinElmer FTIRC 114206, which should be the same as the serial number on the. It will be the same as the serial number on the back. So it'll open in this window. Now, this software will be fairly similar to this one, but it's it looks a bit more modern. Now, for a teaching lab, you'll probably just want to have it looking like this, and just have it fixed like that. But it will always open in however it was left. But to do any setups or instrument setups, you can click on these items here, and this gives you more access to instruments. So this is probably one you're going to mainly use is the instrument setup. So the top right is instrument. Here is where, remember we were saying from 4000 to 450.
Right.
That's where you set it. Resolution is 4. It can do 0.5 if you have a gas cell. I don't know if you have any gas cells. So if you don't, just leave it on 4. That's fine. That resolution's fine for solids. And
Liquids.
and liquid, yeah, that's fine as well. Yeah, it's only gas phase spectra is very fine. If you ever look at an IR of like HCl
Hydrogen bonding and such.
yeah. So
So that's the setup instrument basic tab.
instrument setup, and then
Oh, okay.
it's
Yeah,
setup
that's
basic.
good. Perfect.
So that's I doubt I might change this to 4 in a minute. Well, I'll do that now, and just it will not 41. 4 scans, and it'll average the 4.
Sure.
And that'll be enough for anything probably you would ever run. And then still in the same tab, we have setup instrument beam path. So the nice thing here, sort of if you're teaching a lab, you can show, this is like a pictorial diagram of what's going on in here. So the source is here, it hits a mirror, that's that split mirror pair which is on that axis with 3 mirrors to set up your interference pattern. It goes through an internal J-stop which is set at 8.94 millimeters, so that's already set at a certain
Beam width.
and you can manually adjust that with those plastic cards. Then hits a mirror, and then this is your accessory base, so that's this thing here. So if you have the transmission slide, you can put that in. There's some quick connects on the back of any PerkinElmer accessory. You don't have to use a Perkin-Elmer accessory. The nice thing about the Spectrum 2, it has a nearly full-size compartment. It's probably not much different to that size. So you can use other ones. It just, if you are using other ones, it won't have that that card, so it won't auto-recognize what accessories in there. But it doesn't really matter. It just gives you a pretty picture and it will give. If you put this in, it might. If I set it up, it can have the ATR correction come up, but it doesn't make much difference. But it's auto-recognized. So if we pull this out, there we go. And then that's the detector as well. So it's saying this doesn't know what accessory. Because we can in the larger instrumentation, this mirror's on a motor. Actually, it's on a motor in this one, and we can set the detector to go to a different detector, like an MCT detector if you want high sensitivity, or if you ever get more funding and you want to do FTIR microscopy, we can set this mirror here is on a motor and it flips. This port pops out, and you can add our spotlight microscope if you want to do microscopic analysis of, if you got any forensic type programs. That's cool. Like if you want to look at fibers from a car boot or a car trunk or something. So
With the need for red beam instead of visible.
exactly. So yeah. So
it was a microscope style attachment or something?
yeah, it's fairly large. It's sort of this sort of size, and it's looks a bit like a microscope, except it uses infrared light rather than.
And it gives you kind of an image of this fiber, or
Yeah, so if you watch these my wife's obsessed with them, like these forensic shows where they've thrown someone in the trunk when they're dead and they've picked up the trunk fibers. You can look at those fibers on a slide and then match them. You chemically match them to the trunk, or what else? Or if you look at polymer up close, there can be occlusions and inclusions in the polymer, and because they're microscopic, you can then see, well, is it monomer, which is stuck in there, or is it some other plastic which has come from somewhere? We can do there's it's basically anything, but you can even do a hair on this ATR. So
it's going to give you an IR scan of a tiny little spot.
Exactly. Yeah.
So, whereas visible, I would just see a visible image. Here, I'm going to actually see the functional groups.
Exactly. Yeah. So and this is off the top of my head. Our base model, I think, which is very manual, but it works fine, is around 40,000 Canadian.
No problem.
And the automated one's 120. So, but and then for teaching labs, I forgot about this one. We don't make it. I think the company's called Systech. I think it's a Czech Republic company.
Okay.
They have one which slides into the compartment. I think that's more like 26,000 Canadian.
Okay.
So it's more than this, but
Gotcha.
but
I know.
I don't know. It's if you have a forensic program or something, I don't know. Like it might be a nice addition to if you want to pull funding or whatever. Yeah. Okay, but this is the accessory I feel you'll probably use more than anything else. The big thing is to remember, which when I first demoed this to a customer, I forgot to take the windows out, and they were like, "It's not working." I phoned Brian, the product specialist, like, "It's broken." And he was like, "Have you taken the windows out?" I was like, "No." So if this is an ATR accessory, so the way it works is there's a gold mirror there, there's a gold mirror here, there's a diamond here. So if like a wedding, like an engagement ring diamond, a solitaire, you're seeing the sort of top face of that diamond. The way it works is a beam of infrared light goes off this mirror, goes up into the diamond. A tiny portion of it goes outside the diamond. I think it's called an evanescent wave or something like that, which can interact with any material which is touching the surface of the diamond. It interacts with that, absorbs whatever compounds there, then bounces back through into this mirror, and then into the detector. So
the diamond is hard and it's got like total internal reflectance. It's good visibility.
So that's the that's what it's showing.
All right.
So
That's what we paid for.
yeah, you paid for the diamond.
For the diamond.
I'll wait for Nidra.
So is this going to go back to set to 450 at some point since you set that like that? Once it takes a scan, I presume it'll change this.
Yeah. Well, I'd have to check. It might do. Oh yeah, well, for 450, yeah, it will. Yeah. No. Okay. It was on 450, so I don't quite.
No, it was at 700 when you turned it on.
I mean, but this was. I'm surprised it was at 700.
I get you.
Maybe it needs.
It's funny because we have a variant instrument for UV over there, and even if you do the setup and you change it, the screen doesn't change until it starts to scan. At least that one does.
I think that's the same.
Is it
I
the
think
same
that's
thing?
probably the same thing. Yeah. Okay, so it's auto-recognizing. It's a universal ATR. It's not a zinc selenide crystal. It is a diamond, so it's chemically and mechanically robust. So you'll never be able to destroy the diamond unless you get into the diamond and start scratching it. But we suggest not putting DCM on here because it is actually glued with like epoxy resin.
Okay.
And so you can start dissolving that.
Are there other solvents we should
No, you
be
can
using?
no.
But DCM is just this weird.
Yeah, we found we've been selling this we've been selling these for 50 years, and we're selling the ATR probably for 20 years now. It just DCM. You can do it quickly, but just get rid of it. But you're probably better not using DCM.
Fair enough, yeah.
And also, if it will, this is plastic. This is metal. This is plastic. So DCM will. You can tell people when people have used DCM because you get these drips
So
down here.
we'd have to go old school and use the 2 sodium plates on that old thing, stick them together, and sandwich the DCM.
Yeah, or just put a drop on there and do the scan quickly.
Quickly, okay.
But I wouldn't let students do that.
Fair enough.
But acetone's fine.
Okay, I was going to say acetone or anything.
To clean, the best thing to clean this when you're doing experiments is methanol because it evaporates
Methanol.
quickly. But anything, whatever you've put on there which dissolves is the best. So strong acids. This is stainless steel. You will, if you put like conch HCl on it, you will tarnish this, but it'd be a strange thing to do. So but yeah, just be a tiny bit careful, but don't be panic stricken.
So you don't want them squeeze bottle there and cleaning
Well, you
out,
can with
right?
methanol. You can. It won't.
Okay.
It doesn't make it.
So I forgot. I'll bring it from home.
The best
just
practice
continue
is
to push.
to squeeze the methanol onto a
On
kid
the-
wipe
and then wipe it. Yeah.
or just just wipe it off. You don't not even use any solvent, and then do a scan and see if it's still there.
Oh.
You can check. It's
Fair
very
enough.
quick.
Okay.
But for teaching labs, usually every methanol bottle, you'll see students just spraying it. So as long as it's methanol, it's when it's
Okay.
acetone and they're spraying it because that will dissolve the bib. If you have acetone, 'cause this is polyethylene or whatever.
Okay.
So, but that keeps
Goes
it
over there?
keeps it
Okay.
clean,
Okay.
cleaner.
Okay.
Yeah.
I'll do that.
Yeah, some people use that, some people don't.
How sloppy are people?
We use it.
That's a big bit.
Yeah, well, you've been in a teaching lab, you probably know. Yes,
He knows.
Well, I am the slob because I'm organic.
oh, there you go.
Yeah.
But no, well, it's more to keep the dust, keep it, and then you can just throw that away.
Perfect.
In 3 years' time. No, it just,
I think it's
Just
2
hangs
pieces or
down.
is it one?
Yeah.
it's one, I can put it on if you want.
I thought it was 2 or 3 or something.
No, it's just
Okay.
one with the,
Just need the high chair.
Why don't we just do it?
yeah, we can
Tom?
do it. Yep, there you go.
Okay.
Oh, sorry.
The other way.
It's kind of like this electrostatic kind of
One of those calendars sticking on the wall.
There you go.
Okay.
So, but I think it looks ugly. So that's,
Yeah, you were just saying.
that's why I don't usually use it. Like, so
childish.
that's why I was like, well, if you choose to do it, but like,
Okay.
yeah. So, but no,
Okay.
probably for a teaching lab it makes sense. It's going to last longer. Yeah. So.
You're a student using gloves, right? So.
Oh yeah, for sure.
Okay, so in the software there is CO2. Oh, wait for nature.
CO2 and H2O. That's just like sort of the gas.
So that's
vapor.
atmospheric. So So remember I was saying gas phase spectra is very well precise and well known. So what we do is, I'll repeat this from Najat, is the CO2 and water this correction looks for any gas phase, water and CO2, and will remove it from the spectra. So if it's liquid water, it won't remove it, but if it's, it's in the room.
So it detects that, so to
yeah,
speak?
yeah. So you can even, if I turn it off and you breathe on it, you'd start seeing CO2 peaks and stuff. But so this here, you should always leave this on for a teaching lab, is CO2 and water vapor correction. So it will remove any water vapor or CO2 in the
That's
atmosphere.
pretty sweet.
Now, in the older one, we run a background scan.
Yeah, we'll
which
do a background to get rid of the carbon bonds in the ATR, but this one will just.
Yeah, but the background also sees CO2 and water.
See, we got
and
pictures
sees
on top to
capacity.
show them exactly what you were saying, because they always, the water and then the.
Yeah. So that won't be there in this. Well, it might. Well, it shouldn't be. Yeah. So okay. So this is again instrument setup, instrument basic. Choose your as a teaching lab, you'll probably come back and the students have clicked all over the place, and they'll have changed everything for whatever mad reason they choose to do that. So you just need to make sure these are the sort of, always have it on wave number, percentage transmission, 4000 to 450, 4 resolution, and 4 scans. And for anything a teaching lab will do, that's the universal setting. Yeah.
Do you know how the resolution of that compares to this?
I think it's the same. I can't imagine it's any.
Because we like methylene groups absorb at 460 and 470, but we never can resolve. So with 10 nanometer, 10 wave numbers is never seen as a difference. We'll find out.
Well, we can drop it to 1
Well,
if you want to.
okay.
It ends up being longer scan, but not that much longer.
Is that what that data interval is referring to, or just the resolution? So what the data interval has a checkbox that's not checked, but so
That's a good question. I would have to ask. So you can choose how many. The problem is if the resolution's at 4, having a data interval of 1 is meaningless.
Oh, okay, I see. Okay, gotcha.
So you, from my memory, if you set it at 4, the data points will be every 4. But you can, I think you can force it to do a certain data interval. Yeah. But we can try. We'll try before I go, and we can change it. I probably won't go into this. These are for in industry. You can set all these settings that it will give you alerts if things are out of range. It just isn't. I can't see using that in a teaching lab.
Gotcha.
Okay, so that's basic setup. You probably won't. These are all those industry ready checks. You can set it to at 6 a.m. every morning to do an internal check to make sure it's all working right for the run during the day. I can't see you using any of that. Again, this is all set up, so you can set, if you click peak detect, I'll change it in a minute, you could set up what the thresholds are for that peak detection. In this view is what it looks like. I'm not sure what that is. Library search, it has a small library in there. These are the library folders in there, so we can you can do a search against that library. Yeah.
Given the unknowns.
We don't want to do that.
That's right.
But then, that's set up. So you probably won't ever have unless you're double checking that these settings are correct. You probably won't have these open, so it will just look like this.
Let's say once every month or 6 months we want to run just a general scan to see that the wave numbers are looking proper. Is that something?
Yeah, a good one to that is, you've probably got an old one, is a polystyrene.
Yeah, that thing, behind you there, yeah.
No, I don't really understand that. I'd probably do it in transmission.
That's for.
Or you can do. Or you could. That's what you could. I've never really used this. Or just you've collected semi-spectra. You can even do a bat. It's very easy. That would be on your polyethylene. Or I suppose if you want to do it really properly, you can do we could do a ready check, and it will check. You would click instrument checks, ready checks, run, and then you can, if you're really thorough. You can check, you know, you can check for noise, and it will do a check internally that it's working correctly. I can't see you ever using that though.
Okay,
But you
but
could,
your-
if you wanted
Your
to.
point is, we have a polystyrene strip, we could just stick it here and run it and see it, and that would be,
If you like what you see,
Yeah, yeah,
right?
yeah.
Okay, makes
Um,
sense. I didn't think of that.
Okay, so if you click scan, it will, and it hasn't done a background, it will automatically do a background, or you can force it to do a background by clicking background.
Oh, okay.
So, like,
so let me just understand that. So you click scan, it automatically does a background anyway.
yeah.
So
Well, for the now the way
it's
that's,
been monitoring a background the whole time.
So, well, that's a unique thing to Perkinama. So I don't know if best practice for a student is you probably should get them to do a background every scan. However, we've got this. I can't remember what our acronym. We've got this sort of thing in there which holds the background in there, so you don't actually need to do it. You probably best practice. We probably tell a customer to do it every half hour, maybe. Like it's just not needed anymore. But for a student, in case they ever end up using an old one, or they go to a lab which doesn't have a Perkinama, you probably should teach them to do a background as good practice. But you don't really like once you've done one.
Can
You
we
don't really need to do
do
it.
one with a background, then scan? And
Yeah. So well, let's just do a background.
Yeah.
So
Well, this is interesting because this is a different, this anvil diamond thing, it's a little different than that compartment in a way. It's almost as if the background in this scenario
well,
is a little more constant than I would have thought.
so it will tell you what's going on. So this is the CC bond in the diamond. That's your water peak. That's CO2.
You see what I'm saying, Barry? That's a totally different background than when you're running on there.
Well, this
Because
is-
all we'd see is CO2
This
there.
is very sharp, this is our background.
Yeah.
Yeah. So now you're looking at the diamond
Yeah.
with that stuff.
So that's your background. So when you click scan.
Do you need to put a sample there?
No, so, wait a second, sorry, I need to click preview first. So
Hmm,
always
preview.
have it in preview mode,
Okay.
and then so when we click scan, it'll go in, so it's collecting now, so we can get any old thing you want, so that. So the idea here is that there is no ideal number here. It's when you feel you have a good spectra. So if you did an SOP for the lab, you could put 50 if you wanted, but they're not real units. They're just arbitrary pressure units. But the idea is that you're looking to see when your baseline is flat and you have sharp peaks.
Yeah.
That's-
So if you were to gently loosen that now, you might see more of that ugly baseline thing going on, or and is it going to
It's
constantly
It's
keep?
every 30 seconds, I think it will.
So it'll just keep scanning.
Yeah, it's in preview. Yeah.
So in the old days, we have to worry about covering
Oh, there
that
we go.
chamber and
So
the whole
it's
bit.
lost the.
Yeah.
It's lost a bit of, but yeah.
That
so
makes perfect
You can
sense.
you can maybe have a
Yeah.
figure.
So-
In preview, it just keeps going and going. When you press scan, it'll do it 4 times and
Exactly. Yeah.
Oh, I'm slow. So
Yes.
when it's in preview mode, it's constantly
Yeah, it's
checking
just
what's
checking,
there.
Yeah, so
Yeah.
it's not doing any data collection at the moment. You
I
can
see.
check the energy, the sample, the sync.
So you then click scan when you're ready
Yeah, exactly.
to take a reading.
Yeah, so when you're happy
Okay.
with
Gotcha,
that's
gotcha.
what I wanted.
Okay.
I think that's high density polyethylene or honestly low density. That
So
bag.
it does stop though, like there is a certain,
Yeah.
That's exactly polyethylene.
Yeah.
That's exactly it.
So then so we're ready to go. Oh no, well, let's put a bit of pressure on.
One thing we want is we want more divisions on the x-axis though, so we can actually. I want to make that's 1470. That's 720. I want to be able to show them.
Okay.
you're able to.
Yeah.
Gosh.
I'm always
So take a
stressing on this
scan.
one. I have to do it every time because it doesn't keep it, but I'm going to keep the setting.
Yeah, and the manual labeling on that damn software, I forgot it again how to do it. Like there is a way on that one. You can click on a
You right
peak
click,
and
yeah.
boink and get
Yeah.
something come up, but
Okay.
I'm challenged. So
I've when I did my undergrad, I had used this software, so it would come back to me. But I'm more familiar with this one now.
this looks more better.
If it's ever being weird, it's like any technological thing. Turn the computer off, turn this off,
Okay.
turn it back on.
Okay.
It usually solves 99.8% of every known issue.
The gremlins.
Yeah. So so labels. There you go. You can just click label. It will label it for you.
Oh, there's a percent.
How would you do a manual labeling on, say, that tiny little
So
blip there?
Cursor here.
Cursor.
Well, just
Drag
the
it to where you want to be.
And double click. Gotcha.
And then you can do whatever you want with these. Put them
Perfect.
where you want them to be.
same. That's very similar.
Yeah, well, it's the next, 5 iterations on from where it is.
62.73 wave numbers. Can we reduce the sig figs on that? Like those decimals are just going to be confusing when you're trying to identify. Whole numbers are.
Yeah, some font or number setting. Decimal. Threshold.
I might have to ask the specialist how to do that. That's the threshold.
Somebody writing them down. All 5 sig figure. Come on. Or 6 sig figs.
I might have to get back to you on that one. There must be a way to do that.
Like Excel, where you right click on it and then adjust the number.
And it might be even in the help menu to change the sig fig.
Okay, we can.
You can let us know.
I'm sure you can.
If we have your email, you might be in trouble, or you could forward us to
Oh,
some.
there, Najat's got it.
So, yeah.
I got it.
Yeah, so it's the lithium tantalate detector with
Okay,
the
yeah.
KBR beam splitter. So and then the KBR windows. So the optimal scan range is 7800 to 450.
Right.
However, the detector can. Oh, I was wrong. The detector can do 15,000 to 370.
Wow,
Yeah.
So
Okay. Wow.
it's way up there.
Let's talk about that some other day.
yeah.
So getting more divisions on the x-axis at some
Oh.
point, and also.
Yeah.
Can you Word Microsoft this where you right click on the axis? I know it sounds
Maybe.
ridiculous, doesn't
Maybe.
it?
Yeah.
General.
Oh. Oh.
Label.
Hide x-axis units. It's not checked.
It's the opposite. I know, but I think that would literally get
It's
rid
the
of it.
opposite, so
Yeah,
it's
I
like
think-
Polish style. I'm 50% Polish, so I can say that.
I don't know what that means. Oh, it's
I see.
hiding the units. All right.
Way to go, Barry.
Oh, this is
Tough
just,
questions.
That actually helps you to estimate the wave, even the principle.
No, I'll have to ask on that one. I just don't know.
Okay. So the x-axis and then the
Sig
decimal
fix
place,
it.
yeah.
Yeah, decimals and those.
But if I click around forever, I'll be able
It's almost a little frustrating, eh? Because it seems like it should be so.
I'll phone Brian. That's my go-to.
Brian.
Brian's
He's always-
first.
he's always
Ryan,
there.
tell me now.
Also, that's the thing. So I'm not actually the sales rep for Ontario anymore. It's now Brian, who used to
Oh,
be
really?
the product specialist. So I only sell to cannabis companies now for
Really?
Birkenhammer, just the random role they gave me.
Specialized.
So, so for cannabis, we sell this because they can monitor the THC, THCA, CBD, and CBDA of their. They get all the plant material, put it in a CO2 or ethanol extractor, create a concentrate out of that, and we can tell them their potency using. They put a drop of oil on the top here. So we've repurposed a lot of our instrumentation solely for cannabis.
Just with the latest industries emerging in that,
Yeah.
is the e-cigarette industry also, or is it the cannabis one's big and our grads a lot go there.
Well, it's Health Canada regulates cannabis.
Okay.
So that you need your potency, pesticides, residual solvents, heavy metals. E-cigs, I don't think are regulated.
So
it's
they're
just
oils
a
and-
shit show.
okay, yeah.
But if it's vaping cannabis oil, then that is regulated.
Yeah, the
So-
THC keeps showing up apparently.
Yeah, so well, it's just putting addictive things in there. Maybe someone get Brian.
That could be a forensics thing too at the same time, because now even over in the States, they're really all. That was in the news again this morning.
Yeah.
Another
six-
death
six-
because of these
six
these
people.
e-cigarettes
Oh,
oils.
really?
Oh yeah, in the last 6 months, and they had the head guy there saying something's up because last 6 months
They said
something's
it's
changed.
causing irreversible lung problem.
Yeah, and some teenagers a
And
few
even-
have died now.
Yeah.
They're not sure why.
Hey Brian, so I'm doing the training at Sinclair College at the moment, and they're asking if we can change the x-axis to have more intervals in Spectrum 10. Is there a way to do that, or are we stuck at the? So I've got it set at 4,000 to 450. I think they're wanting, I don't know what you want.
It's going by 500s
It's
at the
going by
moment.
500s. Can we do by tens or
hundreds.
Or hundreds?
Excel.
Yeah, properties, but then no, there's no way
Oh,
to.
is it that one bottom second box not checked from the bottom?
There's like
Auto
units,
range?
auto, x-axis, units, auto.
You see which
Oh,
box
take
I'm
off
talking
or-
about?
Oh,
Second from the bottom? Is it that one?
uh,
Take the auto range off?
okay, I know why.
Oh,
You're not
right.
going to get those units then. So what you're going to do is you're going to double. If you highlight a peak, and then double click, then it will.
Auto.
No, they're wanting the axis. They're wanting better visualization, but so that's the way to do it. To zoom in on the peak, and then you'll
And
get.
the visual
And then it
peak
will
then?
auto. It doesn't. Yeah, and then we can go back to the. So to go
Okay.
back, so any peak you can do that. Draw a box around it. Double click. You can do it again.
Gotcha.
You do it if you want.
Okay.
And then to go back to the main full view is auto XY, and it will
All right.
do that.
Yeah.
Sorry.
And
That's
the
okay.
decimal place.
That's pretty
fill
cool.
it.
So the transmission, the wave number when we peak labels to five significant figures or 2 decimal places. How do we? Is there a way to stop it being so? Is it? Oh. It's in service area. Okay, I'll do it. I'll fiddle around and try and work that out. Okay, I think those. Yeah. Are you available over the next 50 minutes ish? Oh, okay. Yeah, you can pretend. You pretend you're doing very important work. Yeah. Okay.
They're not
Yeah,
going
but,
to use this one anymore. They're going to defect.
Yeah.
what was it?
How do I-
So there's a way to change that. We had too many people complaining about the I'm so crap with Windows 10. How do I get to like the folders?
Well, I didn't download Windows 10. I don't know if it's already there.
This is Windows 10.
Is it?
Is there a way?
Oh, I don't know.
So it's almost like you have to minimize the
Oh.
screen and look for the
If
my
you go-
computer.
Yeah, they don't do
They
that
don't
anymore.
have this PC. They don't have. I think you might have to search. Do you know the file name?
Oh, here we
How
go.
about computer?
Okay.
Well, this is great.
I'm not good on Windows 10.
I'm not saying that we could replace Tom, but this video is Tom.
Yeah.
Or his hands.
Yeah. And my accent as well. Probably no one will understand. They'll go, what was he saying? Like,
We'll be watching it.
Well, some of
When we get stuck.
the students might just like to
We'll
listen.
rewind.
Spectra. Okay, service IR. We'll do that. You might have to help me on this. So there should be a thing in here where we can change the.
Configuration, no.
This is all about the sig figs or the x-axis?
Yeah.
One
Yeah,
of the two?
the
This
sig-
is
the
for
sig
the
figs.
decimal places
Yeah.
on the wave numbers. This isn't critical, Tom. I don't want to hold you
Yeah.
up. So if
No,
you wanna
maybe
get
I'll
back to
shoot
us,
shoot
yeah.
Naja an
Yeah,
email.
email,
Yeah,
yeah.
We
okay.
can do
Yeah.
that later.
Yeah.
Not to worry.
Yeah.
And then if you, and then the other thing, these are all modular. I usually have this one up here, so you can so you can move them wherever you want them. You don't,
Yeah.
they don't have to be.
Just drag it? Oh,
Yeah, you
cool.
can put
Yeah, I
it-
would like that, yeah.
Put it wherever you want it to be.
Can you save the default of where they are? So like if a user comes in and moves them around, can you say reset it back to some default?
No, unfortunately.
Manually move them back.
Yeah. If I had sold the enhanced security software, which we sell to pharmaceutical companies, we can lock it down, except it's $6,000 more. So it was the sort of price thing. But in enhanced security, you can literally all the pharmaceutical end user can do is click scan. They literally can't do anything else.
Right.
So which is sometimes attractive to a teaching lab.
Right.
But it's really quick. You know, you can just. Move it.
Good question.
And then so we can add and remove buttons. So if you want more processing here, we can add
like
it.
the old days.
If you want less process things, if you want to be able to flip quickly between transmission and absorbance, you can have both of those. So you can do it quickly. I can never understand spectra and absorbance though, so I never use that one. Yeah, that's basically it. These are the graph ones. Yeah. So
No, this is really good. This is so much
labels or get rid of labels.
easier in many ways than the old one. This is like,
I'd hope. Hopefully, we've improved.
no, it's like
The 90s or
substantially.
whatever that was. So, yeah. So yeah, it should be. It's fairly easy to use. There's that cursor. You can have the cursor on. So when you want to see that manual peak labeling, if you don't like the peak, just click delete. That's basically.
And then, other than a bag, like a liquid would be the same.
On liquids, you don't put any pressure on because you get intimate contact with the
Putting your
crystalline.
sample through the bag, it's going to read it through the bag.
Yeah. That
Oh no,
was
no,
the
no,
spectrum
no,
of
no,
the bag.
it was the
Oh,
spectrum off the
gotcha,
back. Yeah,
gotcha.
Pretty cool.
Polyethylene. Whatever.
So you put a little tiny, just a drop on there,
Can we
and
do a
then
drop?
Yeah,
Let's
just
go ahead
do-
and drop a
And then we
salt,
don't
salt.
do,
acetonophenone.
Just don't do DCM.
It's weird. DCM is like the only one. I'm so
Well,
baffled by that. It's pretty
It
cool.
just dissolves the glue.
Well, can't you just
Well,
contact the chemists of the research company that
Okay,
built
so-
this and
yeah.
say, what are you
It's
doing?
acetonophenone.
Don't use.
So,
yeah.
so if you had to use that, for example, what do you use, a cleft plate or something else then?
I just wouldn't use it, or
Okay.
use a transmission cell with a
Okay.
KBR plate.
Okay.
So put a drop in there.
Yeah, that's enough. Yeah. So liquids, so that you don't need any of this.
You don't need at all?
Because a liquid
Ah,
because it's a liquid.
So, that's gonna be Jeff. So the light somehow goes up through the diamond, interacts with that drop.
There's an evanescent wave comes outside the diamond.
An
Do you know?
evanescence wave.
I think so. You know fiber optic cables. You know, if you get the angle right, it starts bouncing.
Sure.
But
Total-
there is
total
the wave
reflection.
travels in it's ATR,
Yeah.
attenuated total reflection. There's a wave which travels outside the glass in a fiber optic cable and in a diamond,
Okay.
and that wave on the outer thing of the fiber is what interacts with your sample and then goes in. Now this is one reflection. You can buy different ATRs which have multiple bounce where it will go in, out, and then to the detector. But this is a one bounce one.
So a one bounce, which is like a one interaction incident.
Yeah, exactly.
Okay.
Yeah. So I probably should have told you. So what was this, acetophenone?
Yes.
So this is where you. I think I spelled it correctly. So that's where you label it. You can do a description. If you don't do anything, it will just label it whatever the last thing was, and then put a number against it.
Yes.
So that was
And that would show up on the printout as the name you gave it?
Yeah.
Okay.
So again, so you've put your sample on. You probably usually press scan before you put the sample, but it doesn't really matter either or. You put so it goes into this preview mode. There's acetophenone.
Wow, that's nice.
So it's liquid. You don't need to do any of this pressure
Gotcha,
gauge
gotcha.
business. Click scan. You'll do those 4 scans, and you'll have.
Okay, so I don't know if I'm comfortable with this. Because when they have to make it here, I was very fussy and I have to sign off on the quality, because if they put too much, it's too the peaks would flatten out. It's too concentrated. Now this one is like, anyone just puts a drop on there and it's good.
Yeah.
Where's the finesse?
Now,
Well,
Where's the loss of
with
marks?
that, you would know the thing with a teaching lab.
Progress.
You could teach them how to do that, but they're never going to experience that ever again. So it's sort of like.
so
In your experience, how many of this style machine are out versus the old style when you go to different sites?
If I'm doing my job right,
Right,
there's
right.
more of these.
Right.
But
Are you still replacing a
in
lot of these?
industry, you'd be starting to get harder to find people using KBR. Some pharmaceutical companies do that, but that's more laziness on their part that they can't be bothered to write an SOP for the ATR. So good pharma will, be modern, but sometimes they don't want this. They want to, because they have to rewrite all the documentation and the validation, and they can't be bothered. So they stick to that, but it's very, it's very rare.
So the amount of liquid doesn't really affect the peak?
No, it shouldn't.
You see what I'm saying,
And
man?
the thickness of the plastic is no issue either?
So remember, it's an evanescent wave. So if you, I've got my wallet. Your credit card is a laminar layers of polystyrene of different polymers.
Yeah.
So if you did, I can show you. You can do one side of your credit card.
Yeah.
Do the other side of your credit card because it's made of layers, and it will probably give you a different spectrum
Okay,
because it's
but-
only going
But
to
let's
the.
say I have 6 mil polyethylene versus 1 mil. It makes no difference.
No, it's just the outside.
Okay.
Yeah.
Because it's only getting through the very small fraction
just
of
whatever
the bottom
touches
of
the
the
diamond.
But you see the old style, right? If you put a thick film of liquid, your peaks are all flattened out at the bottom. It looks horrible.
Yeah. Well, that's when you use. So rather than having to dilute it, you can just put those J stops in. It's the same on this one. Put
Yeah.
the J stops
I've never
in and
done
just you weaken the signal
Yeah,
getting to the
yeah, yeah,
detector. So
That's
you-
interesting.
yeah.
Gotcha.
So.
This is cool.
Yeah.
What-
So
well,
so
usually we have-
so if you're in samples view, that's probably the other thing I need to tell you. It's
Put your
gonna
finger on there.
yeah, it gives it. You
Ah,
get you get all,
sorry,
the,
got
you
it
get all
over
the
there.
oil from your finger.
I'm
That's
childish.
usually what I do. Or if you're if I'm demoing it not in a lab, you can put Splendor on there or sugar. We can put anything on
Or
there.
someone's hands are more oily than
You can
others.
say you haven't washed your hands, you're greasy.
And you can just put the powder. You don't need to have it in any meat.
I can show if it's solid. You,
You
have
guys
to
already
put
went
some-
through this? Okay.
If it's
Yeah.
solid, you have to put a bit of pressure on there.
Okay.
But
That's it.
liquid's not. Then gas phase spectra, you would need a gas cell, but you wouldn't have this in there. Then,
Yeah.
so. In samples view, it'll overlay all previous spectra. If you want, so that's that polyethylene.
Stuff, you know.
There's that, yeah. So you just click if you want.
What you want, okay.
Yeah, and if you're in this view, you can. I don't know if you'll ever do this, but you can, if you want to do a manipulation on one of the spectrum, not the other.
Yeah.
You can choose the arrow, and
That's like the old one.
yeah. And then you can do another sample. You can new sample. So if you want to separate them, you can. This is. So it's always saved at this point. It's always in PE data. So once you've clicked scan, you've always got a copy.
really?
Yeah.
Okay.
So,
Now, usually we have students put a text box on there and they describe
Yeah.
the sample, neat, liquid, and
You-
their names and all that mark.
It used to be like a capital A box.
You just right clicked on the
Yeah.
text
Did you come to
Well, yeah, would you-
I'll right click,
and
add text.
It had
Add
text.
text.
Good.
Copy to clipboard if you want to send it. It
Okay.
might be easier to send it to Word.
great.
You
Yeah,
can
thank
set up reports. I think that's what I used to do at university in my teaching lab. You can.
I was going to say the print preview becomes your like report, or is that special?
No, report does. So you click
Gotcha.
report. They ask you what you can report edit what things you want to see in the report,
Oh, okay.
and then show save. I think it will make a PDF now.
Oh,
Oh, no, Word. That's quite nice.
and then if you just go to print preview without the report,
Oh yeah, I don't know what that does.
that's probably what we're kind of more hoping for. So I seen somewhere you had print.
Yep.
Yeah, that's what we normally print.
Yeah.
Yeah,
That's nice.
you can do that as well.
Okay, so that makes sense.
So
yeah.
on the top it says analyst and date. Where would we enter that information?
Sorry, where?
Go back to that print preview.
Oh,
So that would be instead of a text box, for example. See at the top it says analyst and it's over to the right. Gotcha. So you're administrator.
oh yeah.
Okay.
We can. That was a question that you want.
For
We're going to
different
turn off.
users.
We're going to turn off the password because it was annoying.
That's
Because I'm turning the password off at the moment. So when you double click on Spectrum 10, it will just open now. So. The other thing I need to do while I remember is I need to turn off.
Can I wipe it now, Tom?
Yeah. So yeah, wipe off.
I just add methanol.
Yeah.
That's it? Okay.
Yeah, well, so
Kim wipe?
the Kim wipe whatever chemicals off as much as possible, then the methanol.
Gotcha.
Because I imagine,
Okay.
like, if we do a preview now,
Okay.
it's,
We'll see,
it'll,
it'll tell us,
we'll
right?
still have,
Okay, yeah,
it's probably still
interesting.
got
Okay,
a lot on there.
let's see.
Yeah. Well, yeah, because I didn't name it, it's just gone back to that. Oh yeah, so you've got rid of most of it. You've got,
Okay.
you've got
Most of it, right?
Well, you've got a bit of methanol, I think. So.
Just gonna wipe it. Just
I gotta get used to that, Barry. So when the diamond's there, this background is sampling
No,
some
so that it's clean now. Do you see that?
Yeah.
some atmosphere, but also itself.
Yeah, so
So
people
weird.
get a bit worried about the you're losing sensitivity in the 2500 to 1500 range because of the diamond. But if you look here, you're not even at 0.1% your loss of signal, so it's not a worry.
Yep.
Like, yeah.
Cool.
Do we do a powder?
Yeah. Do anything.
let me
Get a
grab
micro spatula or something? We just put it on and
Yep.
twist her down and.
Yep.
You can't use your fingers, can you? Or well, it's menthol.
Yeah. Oh, a bit of crystals there. So this should be a powder, this is a crystal.
Yeah,
We can do- we can
we'll
make a
try it.
crystal.
Yeah.
Can I pick it
That
up
might
with
be
my
when
hands?
you need the.
Take a minute.
Yeah, don't eat it. Although you probably could, but don't.
What is it?
Well, it's menthol.
Oh, menthol.
But I don't think it's food grade.
But
Like in your halls, eucalypt, you know,
Well, I can't read. I was reading methanol.
it's
so
probably
that's not
better
bad.
than food.
menthol. Yeah.
So,
Okay, so.
should I then push this
Yeah, exactly. Swing.
head down?
Let's swing
What
the
do
arm
you
over.
call this?
But such a big crystal, it might splinter in your eye. Fragment. I
What
don't
do you
know.
call
Now,
this
how hard
piece?
can you
said
push
anvil.
it?
Shoe.
It's
and
got that force
you can-
gauge
You can
over
call
there?
it your own name
On the
I think there is
screen?
a-
Oh, okay.
So like 50%ish kind of thing? Is
It's
that?
not. The rule is until
your
you get a spectrum
preview,
you
yeah.
are comfortable with.
But you
That's-
don't go to the maximum force.
It's got a clutch in.
So, yeah.
So you probably will see a student.
But it's every
writing on it.
Yeah.
But
10 or
that's
15
wow,
seconds
they're
it
doing
takes a
that,
scan.
yeah.
So if you like it,
Wow.
like we're good. And look
Yeah.
at look
So
at
there
that
you go.
alcohol absorption. It's not because it's from the
So
solid
you click
state
scan.
Mm-hmm.
where we haven't ground it finally at the same time either. Like I'm just trying to.
So yes, how hydroscopic it is, you'll start getting water peaks and things like that. So.
Right, right.
Well, that's pretty easy.
How much information is that getting by one pass through it?
Yeah.
You're not even officially going through it like
No,
the
it's-
old school.
No, it's a reflectance technique. It's not a.
Like you're sending this photon almost like you're saying just go peek and come back out. Like it's you don't go through it officially.
Oh, and there is I forgot there is a laser in here as well, which that's what's referencing where you are in the spectrum.
In the rotation.
No, I can't quite remember how that. You'd have to look in a textbook, or I'd have to phone Brian again. The laser gets sent in with the interference, as it's going as the source here, which is just a heating element. You'd find on an old style oven. It just glows red and gives off infrared light.
Okay.
That light gets into the interferometer, but then you also, I think, you send a laser beam at a known wavelength into there as well, and then that uses that as a reference to give you, to calibrate from where it needs to be.
No, we didn't give a name to this, so we're.
No, so it came.
You switched over
it
to-
called it Administrator 3.
Yeah, there we go.
So,
Okay.
and it will always go in whatever, if you're in,
Whichever folder.
yeah, exactly. So you can rename that. So that, I always forget to name them, but you can go back, that we can change that to rename to.
So to remove this, I unthread it to release the pressure,
Yeah.
and slide this like
Yeah,
normal.
yeah.
And just kind of see it moving up, that's it.
Yeah. So.
So,
Yeah, there's
okay.
there's two cleaning. So I would
Yes.
you wipe that off in or wherever, and then you also want to so there's two ways.
take
You
it
can
out.
take that off and just clean it, or you can you can pull it up a bit higher while it's still on there.
Actually,
No, Barry, maybe if we
Rub it
had like a vacuum jet and have like a little vacuum trap, you got a little hose just like.
That's a good idea.
Might be awesome.
Right.
Yeah, yeah.
Get rid of most of it like that.
The more you take the shoe on and off, the weaker that O-ring gets.
Sure.
So
That's a good idea.
we can kind of somehow do this, eh?
Yeah, so try and get as much off as possible. Try and get it off the shoe as much as
Yeah,
possible.
yeah.
Then use methanol or whatever the
Oh,
compound
there's still
is.
some there, yeah, you mean
soluble. I can't think what word.
methanol.
Soluble is in. That will get rid of it.
Except for.
Because it's white.
Yeah.
Yeah, it's still.
Yeah, I'm gonna put methanol.
DCM, right?
Yeah, well, you can. Don't. Just
So is it in the
don't put a load of
preview?
DCM on there and just sort of then
One way.
go away. Like you probably can if it's if you have to use DCM, that's fine. Just don't let it sit there because it will dissolve that poly.
And to switch this back to preview where it's pulsing and you're still
Oh,
reading.
just click scan.
Oh, okay. And that just gets it
Oh,
going.
sorry, yeah, that just gets it going.
Perfect, gotcha.
Oh, sorry, I always forget you label the. If you forget though, you just click Halt.
Okay, you can see, yeah, there's a.
You can see it's. I think that's methanol. Yeah.
I like how you get to monitor this in
Yeah.
real time. Now it's cleaner.
But that's why you use methanol because it evaporates quickly. So because you can use ethanol if you want.
Sure.
Yeah.
Okay.
Alcohols are pretty much safe on any plastic. That's always
Yeah,
a go-to.
exactly. Yeah. Water's fine as long as you use methanol. Highlight. Say we'll just pretend these are 0.5, 1, and 1.5. We open those three. You tell it, 0.5, 1, 1.5. You can fiddle with the processing. So you can only do Beer's law with this. You can do chemometric modeling if you buy an upgrade. This will give. Or you choose a peak. You'll be able to see one peak getting bigger, so you choose that peak, and then calibrate. Call it something.
So I can see in the analytical world, if you're taking real life samples, there's just too many interferences.
This is all meant it will try and fit it, but it's meant to allow to make any sense. So, but then you save that method. We just saved it. Save. Then you would maybe prepare an unknown as your reference, and then you tell them to then run that unknown in transmission, and then you click somewhere quant here.
Okay.
Choose the quant method you want, and it will say it's 0.7%,
Gotcha.
wasn't
Now,
it?
to be honest, I do that in Excel, just to read the three different
that as well.
transmittance,
Yeah,
and
but-
I don't have to learn a new software to do it too.
The thing is, in industry, you would make your calibration curve. It would sit there forever, and you just click quant
Yeah.
over and over again.
I
But,
get it.
so that's the.
What about connecting